Welcome back. Today I'm continuing the process to convert my 1981 DeLorean to an electric vehicle. Here behind me is a very special 2019 Chevy Bolt. And what makes it special is because it's one of the first few hundred vehicles to have its EV battery replaced due to the recent recalls. That's right, this salvage Chevy Bolt with nearly 85,000 miles on it has a brand new battery. It was the very first Chevy Bolt to have its battery replaced from my local dealership. This video is going to cover the process for how I got the battery replaced, and then we are going to remove that shiny new battery and disassemble it so it will fit in the DeLorean. To catch you up quickly, we're taking the entire drivetrain out of this Chevy Bolt, the electric motor, the inverter, the charger, the batteries, everything, and swapping it into the DeLorean. This is Project Lightning. Clearly, a lot of people had questions about whether I'd be able to get the battery replaced, since this was a totaled vehicle with a salvage title. As I mentioned in a previous video, so long as the car runs and drives, it would likely be eligible for a replacement, and in early October, I called GM to see if they would honor the battery replacement, and after being on hold for a while, they came back and said, "Is your car operable?" And I said, "Yes, it runs and drives fine." And they said, "Great, then yes, it is eligible." But that was just the first hurdle, because there are 140,000 bolts with batteries that need to be replaced, and it will likely take years for them to all be replaced. So GM is prioritizing higher risk vehicles. Purely by chance, my car had a build date of October 2018, which put it at a much higher chance of being defective. Roughly 1 in 300 bolts produced in that month have caught fire. GM began replacing batteries in mid-October, and on October 20th, I checked the online recall information about the car and saw that my VIN was moved into the high priority parts available category. After a few weeks of working with my local Chevy dealership to get a battery, I finally got one shipped out and installed in the car in late November. On December 1st, the car was ready, and I've now got the Bolt back here in the shop. It has made its last drive off of the tow truck and onto the lift, and I'm nervous to say that this Bolt will never drive again until it's resurrected in the DeLorean. Before starting on disassembly, I fully charged the battery in the Bolt and got some diagnostic information. Then I've turned the heater on in the car to full blast and let it run for a few hours to bring it down to about 20% battery capacity. This is a low level, but not low enough to potentially degrade the battery if it sits like this for a month or two, and I'm doing it partly for safety, since a 335 volt pack is slightly less able to kill me than a 400 volt pack, and because when lithium-ion batteries are charged, they expand a little bit. Since I'll be disassembling the modules, I don't want to put any more physical stress on them than I have to. I'm now going to follow the service manual procedure for disabling the high voltage battery pack. I remove the key fob from the area, I'll put it in the house, then pop the hood and disconnect the 12 volt battery with a 10mm wrench. Then I'll put my 1200 volt safety gloves on and remove the manual service disconnect from the battery in the back seat area. The battery pack should be disabled now, but to make sure, I'm going to test the voltage at the high voltage power distribution module. I'll disconnect the high voltage cable that runs to the inverter, then confirm that there is no voltage between ground and either of the pins or between the pins. The car is now raised up, and I can disconnect the main battery pack. Let me show you all of the connections to the pack, Starting on the passenger side, we have the slow AC charge port, the cooling inlet and outlet, then the main pack connector, followed by 2 low voltage connectors and 2 ground straps. I'll first disconnect the high voltage charge plug and the high voltage main plug and check, like I did before, to make sure that there is no voltage present on either the battery or the plugs. At this point, the battery is safe, at least until I crack it open, so the high voltage gloves are no longer necessary. I'll remove the 2 low voltage connectors from the battery, the wiring harness strap, and the 2 ground posts with a 10mm wrench. The last items to disconnect are the coolant lines. I'm going to disconnect one, let it drain a bit, then disconnect the other. I tried to use compressed air to blow out more coolant, but it didn't work very well. Then I plug the lines with paper towels. I'd like to also introduce a new member to the Project Lightning team who's going to be helping out around here for a little while. So please give a warm welcome to Bench to the Future! Bench to the Future is going to be the temporary home to all of the Bolt EV's components, while I disassemble the car and the battery, and I'll mount things up to it to test everything out. It's made from 4x4 lumber, angle brackets, structural screws, really long lag bolts, and construction adhesive. The top is spaced to the specifications in the Chevy Bolt recall service notices, and it can hold the entire weight of the Bolt. The casters are the largest and heaviest duty ones I could find on Amazon and are rated for 3,400 pounds. I built this in about a day, and it cost about $300, of which $100 was for the casters. I'm introducing Bench to the Future because its first job is going to be to hold the battery pack. I'll put Bench to the Future in place directly below the center of gravity marking on the battery pack. Then lower the car down. As soon as the bench takes some of the weight off the car, I can remove the 5 bolts from each side of the battery that hold it in place. These use a 15mm socket, and the 2 bolts in the rear of the pack are much longer than the rest. In a proper shop, they would use a hydraulic lifting table for this task, which is safer, and also $4,000. Once the bolts are removed, I can lift the car back up and out of the way, leaving the battery pack on the bench. Or at least that's what's supposed to happen. I didn't set my lift properly, and it got hung up on the rear of the pack, so I had to put the full weight of the car on Bench to the Future and readjust it, which fixed the issue. The battery is now ready for disassembly. So this is your very first look at the final remedy replacement battery for the Chevy Bolt. So here's the little side stickers. These look all familiar. Some people have also seen the N2.2 sticker there. It looks very similar to the other battery packs. Wanted to show this little QR code. And then just like the back, that sticker also has a replacement sticker sitting on top of it. Here on the top of the battery is a recycle thing and information about how to lift it with a forklift. I don't know if these kinds of quality assurance marks are the same as they were before. There's like a green check and then 2 yellow marks there. Of course, the don't step. This is, of course, plastic or fiberglass, but the bottom is steel here. So that's very thick, strong steel. Before I jump into the disassembly, I need to get some specialized tools. Since I'm working on a battery pack that can be over 400 volts and can easily source thousands of amps of current, I need to make sure that I don't use metal tools, because if I accidentally short the battery, it would be incredibly dangerous. It would throw sparks and could start a fire. It could also destroy the battery. There's also the obvious potential to be shocked and killed by such a powerful battery. You can buy a full set of insulated screwdrivers, pliers, and sockets on Amazon. And it's $2,000. Yeah, I can't justify that. I do know that I'm going to need some screwdrivers to help remove connectors, so I picked up an insulated set rated for 1000 volts for $35. Very reasonable. I also bought these insulated socket isolators called eShock Guard. They cost $10 to $15 each and are also rated up to 1000 volts. I got all of them, including the 3/8 and 1/2 drive versions that I think I'll need the most. I've also got these high voltage insulated rubber gloves. This is not a suggestion to open up your battery pack or to disassemble it. If you are like me and not trained to do it, it's quite dangerous. You probably won't ever get it working right again. It's stupid. Only an idiot would do it. And the first step in disassembling the battery pack is to use a 10mm socket to remove all 50 bolts around the edge that hold the top cover of the pack on. There are also 6 bolts that hold the manual service disconnect lever. These also use a 10mm socket, but the bolts are slightly shorter. Once those are removed, the top cover of the pack can be lifted off. With the cover removed, let me walk you through the major components of the Chevy Bolt EV battery pack. The shiny aluminum plates that you see are pressed directly against the individual battery cells, and those are packed together into battery sections that extend the width of the pack. There are 5 of these battery sections, and the 5th section sits on top of the 4th. Each of the battery sections is made up of 2 battery modules, and those modules are connected with bus bars. These bus bars are each wrapped in an orange plastic housing. At the top rear of the pack is an orange box, which is the connector for the manual service disconnect that was removed from the back seat earlier in the video. Next to it is a black rectangular box called the Battery Energy Control Module, also known as the Battery Management System, or BMS. Up front, there is an orange housing that contains the high voltage contactors that turn the pack on and off. Running down the sides of the pack are 2 electrical harnesses, a black one for the low voltage wiring and an orange one for the high voltage wiring. The pack also has an integrated cooling system, which I will cover in more detail once it's visible. At this point, I have to get my safety gloves back on, and I can continue with disassembly. I'm going to follow the service manual procedure to disconnect the BMS. This involves disconnecting the low voltage black wire on the driver's side. These connectors all have little clips that have to be undone before the connector can be removed. Then I'll remove the low voltage wire on the passenger side. Then remove the high voltage connectors on the passenger side, moving back to front, and then the high voltage connectors on the driver's side, moving front to back. The next step is to remove all of the battery bus bars. Each one has a small plastic clip that covers the post on the battery module, and then you can use a 10mm socket to remove a nut from each one and disconnect the bar. I'm also using a small magnet to pick up the nut, because these gloves make it impossible to do by hand. Once both sides are removed, the bus bar can be pulled up and off the pack. I'll repeat this for all the remaining bus bars and the manual service disconnect. I'm also going to disconnect the BMS connections on each battery module. The modules each have two connectors for the BMS, one on the front and one on the rear of the pack, and all of those will now be disconnected. These have a white locking clip on the side holding them in place that is very annoying to remove. Once the battery has all of the high voltage components disconnected, the pack is much more safe to handle. When the bus bars are in place, all of the voltages of the modules add together. That's how we get 350 or 400 volts. But when they're removed, the maximum voltage from each module is only 40 volts, and I'm currently reading 35 volts. So the high voltage gloves are no longer required. However, each one of these batteries can still supply 1,000 amps at that voltage, so I still have to use insulated tools to prevent shorting anything out. Moving up to the front of the pack, I first take off the cover for the high voltage battery disconnect relay assembly using a 4mm hex bit. This gives access to the bolts that hold it to the battery frame. These bolts require a 10mm deep socket, and to remove the bus bars and main pack connector from the relay assembly, you need a 5mm hex bit. I'm going to remove the main pack connector with a 10mm socket, and then the charger connector with a T20 Torx bit. The same bit is used to remove the low voltage pack connectors. I'll then remove the harness from the contactor pack, and then use an 8mm socket to disconnect the charge port connections. The relay assembly can then be pulled out. I'm now going to remove the clips from the low voltage and high voltage harnesses on the driver's side, then remove the high voltage harnesses back towards the BMS. The low voltage harness also has temperature sensors that slip into the ends of some of the battery modules, and they can be pulled out. The low voltage harness can then be removed. The low voltage harness on the driver's side also has a ground wire that needs to be disconnected with a 10mm socket. This same process will be repeated on the passenger side of the pack to remove the high and low voltage harnesses. The next step is to start unbolting the battery sections. There is a set of brackets on the top of the rear platform that the BMS and manual service disconnect sit on. That needs to come off to get access to sections 4 and 5, and all of the battery sections are held in place with a bunch of nuts and bolts that require a 10mm socket. The left and right sides each have 3 nuts, plus a nut on the front and back, right down the middle of the battery pack. They also have brackets that sit between each set of battery modules that have 3 bolts holding them down. Once all of the bolts are removed, we can take the brackets off of battery section 5, then hook up the engine hoist and lift it up. They make a tool to assist with this, which is basically a metal tube with some metal fingers that grab the sides of the battery section, but it's about $500, so I'll make do without it. This did end up putting some small dents in the metal heat shield on the sides of the battery cells, so I think if I did this again, I'll use a load balancer or something like that. Under the pack is some incredibly sticky heat transfer material, And as it releases from the heatsink fins on the battery, it makes quite a bit of noise. It sounds like an aluminum soda can being flicked. I went slow, and the section was slowly lifted up. These sections each weigh about 150 pounds. Once battery section 5 was removed, I covered the heat transfer material in cling film. I don't know how well this is going to work, so I'll report back in the future. And then I remove the next set of bolts that hold this cooling plate down and use a set of pliers to loosen the clamps on the cooling tubes that connect the upper cooling plate to the lower cooling plate. Then I can remove the upper coolant plate and the foam padding that sits under it and remove some more bolts. The upper battery structure can now be removed, which gives me some access to take off these two small high voltage harnesses for the battery modules that are under the shelf, and remove some more bolts. At this point, all of the bolts are removed, so the remaining brackets between battery section 3 and 4 can be removed, along with some more nuts that hold battery section 4 down. This finally means that all battery sections are free to be removed. With the battery sections removed, I can cover the heat transfer pads in cling film and then remove these support bars that extend the width of the pack with, you guessed it, a 10mm socket. There are 2 bolts on each end of each of the bars, and then they lift up. I'll now remove the very large nuts that hold the coolant inlet and outlet ports on. I don't know what size it is, it's over an inch, so I used some adjustable wrenches on either end to break them free, and then spin them off by hand. There are short black tubes that connect the front ports to the battery coolant plate, and they are really stuck on there. It took a lot of force to remove the connectors, even with squeezing the tabs, but eventually they popped free. The bottom cooling tray can be unbolted now. There's 16 nuts holding them down. Make sure you wait until after the coolant tubes are removed from the front. If you try to remove the tubes while the tray is unbolted, you'll end up lifting the whole tray, which might be why it was hard, so learn from my mistake and remove these after. Then, you can pick up the coolant plate and remove it. It's fairly thin aluminum and pretty light. The last thing to remove from the pack is the foam pads. They are held on with a single small piece of double-sided tape, which you can use a pry bar to easily remove. With the pack disassembled, let me go over the cooling plates. The main cooling plate has 3 ports on the front and another 3 on the rear, with channels connecting the front and back. These channels do not connect to each other. The inlet port on the battery pack splits into two and feeds coolant into the outer channels, which then exits the rear of the pack and goes through short hoses connecting it to the top cooling plate. The top cooling plate is effectively a T-fitting, where the two outer channels combine into a single outlet. That outlet heads back down the main cooling plate and makes its way out the outlet port. And with that, this brand new battery has been completely disassembled. If this seems like a fun project, you will not want to miss out on the next episode. So please show me that you're interested and give me your support by subscribing. This is Project Lightning.